guys, in today's video, I'm going to be continuing with integration, but today I'm going to be discussing definite integrals. Definite integrals is finding the area under the curve, but they've given us two limits, a upper limit and a lower limit, and we have to find the area between these two limits. So this is how it looks. So if we have integration of f of x, the limits are a to b. B is the upper limit and B has to always be greater than A. And while integrating in definite integrals, you never add a constant. So you never put plus C. So you never do this. So once you do this and integrate it, I'm just going to write the integrated form as capital F of X. So this is the integrated form. And now this is A to B again. So what you do is you substitute B. So f of B minus f of A. So this is the value of the definite integrals or the area under the curve between A to B. So to give you more clarity, I'm going to be discussing few more examples. So if we have integration 1 to 2, 2x cubed, and we have to find the area between the curve in these 2 points. The first thing we do is integrate this. So 2x cubed is 2x to the power of 4 divided by 4, and then you add the limits. So now you can cancel out this and this. This becomes 2. So you get x to the power of 4 divided by 2. The limits are 1 to 2. Now we substitute these. So we get 2 to the power of 4 divided by 2 minus 1 to the power of 4 divided by 2. So wherever x is, you substitute the upper limit and the lower limit. So now this becomes 2 to the power of 3, which is 8, minus 1 by 2, which is 7.5. So this was the first example of how to find the area between the curve. Now I'm going to give some more examples. So if we have integration 1 to 4, 5x to the power of 1 by 2. The first thing we do is integrate this function. So we get 5x to the power of 1 by 2 plus 1, which is 3 by 2, divided by 3 by 2. And then you just add the limits, 1 to 4. So now this 2 goes up, so you get 10x to the power of 3 by 2 divided by 3, 1 to 4. And now if you substitute 4 in this, you get 80 by 3. So you basically get 10 into 4 to the power of 3 by 2 divided by 3 minus 10 into 1 to the power of 3 by 2 divided by 3. So the value of this is 70 by 3. So this is the value if you input it into a calculator. So now if I move on to another example, example is 1 to 3 integration 4x square. 1 second. 4x square plus 12x plus 9 divided by 3x. And if we have to find the area between the curve in this, the first thing we do is we make it as integration 1 to 3. You divide 3x from all terms. So you get 4 by 3x. And 12x by 3x is 4. And 9 by 3x is 3 divided by x. So now this is very easy to integrate. So you get 4 by 3 x to the power of 2 divided by 2, so into 2 in the denominator, plus 4x plus 3 into x to the power of minus 1. It becomes x to the power of minus 1 when you move it up. But you can't use that rule. As 3 by x, you have to write it as 3 ln x. This is a formula. 1 by x, the integration, is equal to ln x. Because if you move it up and add 1, you get x to the power of 0 by 0. So that you can't have it as that. So now you get it as 4x squared by 6 plus 4x plus 3 ln x. Sorry, plus 3 ln x. And it's 1 to 3. Now if you substitute this into the calculator, you get the value as 16.63. So this is the value when you substitute 3. So f of 3 minus f of 1. And remember that while solving definite integrals, you never add a constant plus c. Okay, that's it for today's video, guys. In today's video, I introduced a new topic called definite integrals. Thank you.